Hey, now I made a delay effect. This one here. That is the sound without the delay, so let's try with that delay. That's really low fidelity delay, and name of that actually is no-fidelity delay. This is the better quality delay that it has two settings. It's not based on that BT2399 something numbers chip that almost everything is, but Arduino Nano, and Arduino Nano without anything extra has 2 kilobytes of RAM, and you need RAM to have the delay buffer, and because having it process audio also takes memory, so this has like half a kilobyte of memory for that delay buffer. And if you need with 8-bit bit rate, you need one sample per sample. So this sampler rate will be very low, which will have lots of aliasing and loss of high end. So that's the result. But the maximum time is like very short for a delay, quite long actually for this kind of thing. But when we go to the no fidelity side, delay time is longer and the sound quality drastically changes to something barely representing what went in. Because when the low fidelity side uses 8-bit samples, this uses 2-bit samplers, so I can have 4 times the amount of samples and 4 times longer the delay, and actually this also lowers the sample rate, so that destroys the sound quality even more. But that actually sounds somewhat reasonably what is going in, and 2-bit samples would only have 4 different levels for the sample to be like with the 60-bit audio, for example in CDs, or this video has that 65 something thousand different levels. 2-bit would have only 4, and that would basically mean that you only have like a couple of different square waves. So this actually doesn't use that kind of normal pulse code modulation, but some kind of asymmetrical 2-bit differential pulse code modulation. I don't really know what would be the real name for that, because I didn't bother to check out, and the math went way over my head, or I was too bored by it, so I just designed my own. So basically, when normally you just save the value of the sample, the differential thing saves how much did the sample go up or down from the last one. Like the 8-bit Nintendo saved is as a normal 1-bit differential pulse code modulation thing, so it only saved true or false. The sample goes up or sample goes down. And if you can anyway visualize that, if you have a square wave, it's what you save is not going to be a square wave, but very slowly rising triangle wave. So you would usually want to have higher sampler rate for that, and this combines that kind of idea with low sampler rate. So yeah, and also because you only in the 1-bit thing you only save is the signal going up or down. If the signal stays the same, it still needs to save that go up or down, because it has only 1 bit, so 0 probably goes like down. So if you have silence or square wave, it oscillates and it sounds horrible. So now, because I have used 2 bits for that, I can have signal going much up or much down or little up or don't go at all, which makes it asymmetrical and creates very, no, well, not very, but somewhat unique sound. Well, don't think this as a delay effect, think this as a effect. And now it's feeding back eternally. So let's play with that. And let's try turn the dry signal off. So this is only what is generated from the eternal feedback and whatever I play in. Also, there of course is CV inputs for, well, the time and feedback. So let's destroy this a bit more by having the time modulate with this LFO. Well, it helps if you turn the mix up. And of course that works also with the well, higher quality thing. And you can try to have a chorus effect, which is basically slowly modulated, very short delay, but also, there's the lo-fi, no-fi switch. This switches the dry signal on or off, so you can have only the delayed signal, and mixes the volume of the delayed signal. And well, CV input for time and feedback, and gate. It's like basically two diodes not clipping the signal, but parallel on the signal, so it tries to take a bit of the signal away from around zero. I was thinking that it could maybe lessen some kind of digital noise that you get from here, but I don't really see difference there. Well, I need to maybe do I need to do a couple of changes here, because the dry signal is actually inverted. Yeah, and if you have the longest setting, the signal volume goes quite down from reasons. It's filtered strongly, and the differential pulse code modulation really starts to eat away lots of the signal level too. So replacing the mix knob actually with crossfade from the between the clean or the dry and the delayed signal would actually be better. So if you have settings that the delay volume goes way down, you could still have it balanced with the dry signal. Or I'll just replace that with configuration that it can be used basically as a soft clipping distortion, so you can have a torta per torta, distortion, because the gain here is also well, guitar players know it, the type scream type soft clipping distortion, because you really want to have all the signal level you ever want with this, because the 8 bits is not much, and well, it's even lower because you need to sum the feedback. The feedback is actually done internally, so you have a digital feedback there, so you can destroy the signal when it goes in, then the digital part destroys it even more, then you filter it, and then you can destroy it more, and you have whatever this is. Beautiful, or maybe that depends on what kind of sound you like. Yeah, there's no really point of going through the schematics. You can check it for yourself. The filters are tuned by ear, or I put something what I had there and talked about maybe these filters away the output noise, and well, it does. It probably filters lots of the signal too, but well, what do you do? The code is currently in horrible shape, so I won't show it. I try to make it a bit more understandable, or at least not so ugly, and have that on GitHub too. Once I manage to crash this, I need to check out what is the problem there. Maybe I need to add one button there that says like a reset. Switching it between the lo-fi and hi-fi actually does like a semi-reset. It empties the internal delay buffer, because the differential pulse code modulation thing needs to really get on track what is being played or written and read, because every output sample is relates to previous sample. So if you ever break that chain, you will have bad time or bad noise or something really nonsensical. If you make noise, maybe you would like it. So maybe I should have a button here, break everything. Yeah.